This is Algebra 2, Chapter 12, Section 1, Part A, in which we will study trig functions and right triangles. There's a lot of stuff in this section, so I decided to break it into two lessons for you. We'll obviously do the first one here, and then we'll do the second part in the next video. When we talk about trigonometry, what we're talking about is studying how the angles and sides are related in a right triangle. Now, for whatever reason, mathematicians have decided they like to use the symbol theta, and it's a Greek letter, to represent angles. We like to use Greek letters for all of our angles when we can, but theta is typically the one we talk about the most, and it's just an acute angle. And we name the three sides of the triangle based on where they are relative to our theta. Okay. And when I say that, I'm talking this way. If theta is this angle down here, then this side across from it is called the opposite side. The side next to it is called the adjacent side. And the hypotenuse is always the one across from the right angle. And you'll notice there's some shorthand here. Op, adj, and hype. Okay, just to simplify things for us, make it where we don't have to write as much. There are 6 different trigonometric functions, and I have them listed here for you. Sine, cosine, tangent, secant, cosecant, and cotangent. Sine is defined as being the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. Tangent is opposite over adjacent. Secant is hypotenuse over adjacent, or you could say secant is 1 over cosine of the angle. Cosecant is hypotenuse over opposite, which is 1 over sine. And cotangent is adjacent over opposite, 1 over the tangent. And you have 2 different ways you can find this. You can either use the ratio here, or you can use 1 over the value you got from up here. Either way works for me. Right, there's a little memory trick for how to remember which one of these ratios goes to which thing. It's called SOHCAHTOA. The letters here spell it out for you which ratio is which. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay. If it helps you to remember it, feel free to use SOHCAHTOA. There's another one out there about horses and oats. If you want to ask about that in class, you can. Or you can just refer to the chart over here. So they are going to throw things at us like this. They're going to tell us sine of b is equal to 5 over 8. And they want us to figure out the other 5 functions. Okay. Now remember, sine is equal to opposite over hypotenuse. From b, the opposite would be over here, and the hypotenuse is the one across from the right angle. So sine of being 5/8 means the opposite is 5, and the hypotenuse is 8. Now all we have to do is figure out the third side, and for that we use our old friend the Pythagorean theorem. A squared plus b squared equals c squared. Well, cleaning up the arithmetic, we'll subtract the 25 over and take the square root. So now we know what this third side is. This one would be the adjacent side to b. It's the one next to B. Now we have all three sides. We can do the ratios. So cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Secant is the hypotenuse over the adjacent. I'm just referring back to the previous page with the ratios they gave us. Cosecant is the hypotenuse over opposite. And cotangent is the adjacent over the opposite. Now you'll notice I didn't divide any of these ratios to get decimals out of it. We could have, it's perfectly acceptable too. But for my purposes right now, I'm really more interested in you being able to use the ratios. So I'm going to leave them in that form. We'll deal with what the decimals mean later when we get to it. So what are these trig ratios usable for? The idea is we can use these ratios to find information that's missing in a triangle. Okay. And there's two key questions you need to answer to know which one of the ratios you need to use. And the two questions are, what information do I have? And what information do I need? When you can answer those two questions, then that tells you which ratio to use, whether you use sine or cosine or whatever. Okay. Having the information that's given to you and having the information you need to find helps you know which ratio to use. So let's do a couple of these. They've given me a right triangle. I've got an angle 24. I've got a side over here that's x, and I've got a side that's 18. Okay. Everything we're going to talk about is based on this angle that we know. What do we have? What information do we know for certain? We know this side for certain. That side's across from the right angle. So what we have is hypotenuse. What do we need? We need this side. Okay. That side from here is the opposite. Now we need to look at our ratios and decide which one involves hypotenuse and opposite. Well, there are two of them that do, but one is really more useful than the other. Sine is the best choice here, because sine is opposite over hypotenuse. So we're going to write that equation. Sine of our angle equals the opposite over the hypotenuse. Now we're going to go to our trusty calculator. We're going to make sure it's in degree mode. If you're using the classroom calculators, the calculus class needs them in radian mode, so they'll be switching to radians. You'll be switching back over to degrees. So sometimes you'll have to check that. If you need help getting your calculator in the right mode, just ask. I'll be happy to show you how to do that. But when you do sine of 24 degrees, you should get 0.407. Okay. Now that's what x over 18 equals. I don't care what x over 18 is. I need to know what x is. So I'm going to multiply by 18 and get my answer. Okay. Let's tangle with another one. We have a 36-degree angle. We have a side of 11, and we have a side marked for x. Okay. What information do we have? From here, this 11 is the adjacent side. What information do we need? We're looking for this side, which is across from the right angle, so we need the hypotenuse. Well, adjacent and hypotenuse, this sounds like a job for cosine. So cosine of 36 is equal to 11 over x. Okay. Trusty calculator again, cosine of 36, it tells me is 0.809. I'm going to multiply by the x to get it out of the denominator. And then I'm going to divide by the 0.809 to find out what x is. So we talked about the 6 trig ratios. We talked about how to use them to find information in the triangles. And we talked about how to use them to write ratios. Again, remember your calculator needs to be in degree mode, but if you need help with that, I can help you out. If you had other questions along the way, hopefully you wrote those down. Bring them in with you, and we will see you in class.